My name is Colin Thomas, here at the University of Notre Dame, and this is leveraging intermediate data management with Parsl TaskVine. For those of you who are not familiar, the TaskVine executor is one of the executors available for Parsl. It's based off of the TaskVine workflow system where the focus is on data management and using the local storage of nodes in the cluster. So the ways in which the local storage is used is through caching of data and through peer transfers or asynchronous transfers in between workers that can occur all within the cluster. And one thing to keep in mind is that in any situation, so whether or not you're using the TaskVine executor at the moment, the outputs of tasks are returned back to the user. They're written back to the shared file system. And that makes sense because we need to use those. Maybe we want the result of a task that we ran, and maybe that result is a data dependency for a subsequent task, and so on. So everything comes back to the user. And if we think of an ideal workflow, such as this DAG here, we've got some sequentially dependent tasks. If the blue squares are files and the green circles are tasks, we have a set of could say 5 sequentially dependent task groups. So there's 5 layers here, each of which produces and consumes some set of files that are dependencies for a next group of tasks, with the exception of the last layer. But if we ran this workflow on the shared file system, and we think about the sort of data access pattern that workflow is going to be performing, it more so looks like a flat graph. These tasks, they still can't be executed out of order, but the way the data is moving, each first layer file is a hit on the shared file system. And so we're running a task, we're producing a file, we're writing it back to the shared file system. The next task is going to read that out of the shared file system and produce its own file and so on. And this sort of access pattern graph will just explode horizontally as you scale up your workflow. And this is one of the things that TaskVine likes to work with and run experiments with. So one of the more newer, more interesting features of TaskVine is this notion of temporary files, which is our way of dealing with intermediate data. And that the intermediate data is the data in this DAG here that is neither on the beginning or the end of the workflow. So it's this data that appears in the middle of the workflow. It's consumed by some tasks afterwards, and we don't really need this data. It's not necessarily interesting to the user to read it. It's not the result we're looking for. It's just a dependency that's created inside the workflow that subsequent tasks need. And with TaskVine temporary files, these files are created out in the cluster on the local storage of the nodes we're using, and they are not sent back to the manager. They're not sent back to the user or the shared file system. They're kept in this local storage here. And when they are needed as subsequent dependencies for tasks, either the TaskVine executor will schedule these tasks to a node that already has that file cached on it, or we can schedule a asynchronous transfer to get the data where it needs to be in the cluster, so we can run these tasks without using the shared file system as an intermediate destination for that data before it gets to the node that is running the task it needs. So some of the benefits of this method here is if we create a large amount of data as intermediate data in a workflow, it could easily share or fill the shared disk space allocated to some HPC facility user. we could make just a huge amount of files in general where it's not so much the size is an issue, but just the amount of files can start to cause metadata issues. Um, and also the cleanup of the data after the workflow is not a insignificant part of the workflow. Like if you're generating 25 or 50,000 files that all come back to the shared file system, and when you're done with your workflow, you're sitting here with a ton of files in your directory. It could easily take, a minute or two or much more to remove and clean up all that data before your next run. And this is data that you're not really interested in because it was an intermediate product of your workflow. So with this addition to the TaskVine workflow system of intermediate data, there also needed to be some supportive features involved because if we are not writing this intermediate data back to the shared file system, it's sort of vulnerable out there on local storage because we could lose any given worker. We could lose it at any time, especially when we're using the opportunistic resources like HD Condor. And so we have some more supportive features to work with this intermediate data. The first of which is data recovery. So we can, if we lose some file of intermediate data, so we lost a worker that has that file, and now it no longer exists in the cluster. We can track the provenance of that file back to a point at which we can execute and recreate that intermediate data. So we backtrack, one or more tasks to recreate that file, and this can get kind of expensive depending on how intensive your tasks are. So we also have temp file replication, which the user may configure, where as intermediate data is created, we can just asynchronously replicate it across different host names in the cluster. And this also serves as sort of a non-committing way to stage data for the future because we're not necessarily thinking about what tasks we're going to execute in the future because that would require, at least we're not thinking about that yet, because that would require a lot of committing to running a task on a certain host, which has a lot of complications. But just replicating this data in general tends to stage data for future tasks with some effectiveness. But also this helps. So if you lose a worker that had some intermediate data, maybe we replicated it over to a different host name in the cluster so that data isn't totally lost and it's still available for future execution. And we also have transient error accounting. So with the peer transfers in the cluster that we schedule with the TaskVine, sometimes you'll try to open up a connection between two nodes in the cluster, and for whatever reason that transfer fails. It's not that either of those workers necessarily failed entirely. It could just be some sort of ephemeral transient issue, and these things happen. And so we don't necessarily consider them to be failed, either of those nodes, but we'll just avoid trying to schedule that same transfer again. We'll go look somewhere else for this data transfer that we want to perform, and try and avoid that worker for a period of time. So with these methods, I made some preliminary changes to the TaskVine executor, where we can declare temporary files, declare intermediate data in a Parsl TaskVine workflow. And this application Parsl doc was the first sort of evaluation opportunity that I ran this on, and it's a relatively good opportunity for this technique because it creates a lot of intermediate data. And a little bit about the workflow here. So this DAG here actually is a pretty small version of an example of this application. So this five layers of sequentially dependent tasks. Um, this is very small. If we were to scale this up to a normal run, it would be much larger horizontally. But these five sequentially dependent tasks creates a lot of intermediate data, as you can see all those blue squares. And the base case is 10 batches of 100 task sequences, where each sequence has 5 sequentially dependent tasks. And it's doing a molecular simulation workflow, training a machine learning model to fit proteins to receptors or do this process called docking. And I actually saw this application presented at Parsl Fest last year. So the preliminary results we have, it's not running at an exceptional scale. We've had a little bit of scaling issues at our own facility, actually. So the TaskVine plus temporary files ended up having the fastest execution time here. And the TaskVine base, so this is not using the temporary files, just the TaskVine executor with Parsl had a marginally slower time. And like I said, this isn't an exceptional scale here. So this is pretty reasonable that it showed only a marginal improvement. And then the high throughput executor, so this is without TaskVine, ended up being the longest execution time. And if we look at these graphs here, these are from left to right in order from the TaskVine temporary, TaskVine base executor, and then high throughput executor. We can see these 10 batches of tasks that are being running. So the y-axis on all of these graphs is each task in order of which it is being run. So there's 5,026 tasks in this workflow. And the x-axis here is just the time that it's being taken to run. So each one of these sort of stair steps is one batch of 100 tasks. Between the TaskVine temporary version and the basic version, it's just the stair steps are marginally steeper for the one that ran in quicker time. In the high throughput executor version here, we can see some sort of long outliers, which are pretty consistent through the runs that I've been doing, which I think I can ascribe to the shared file system bottlenecks, because this is creating a lot of intermediate data. It's creating, like we can see here, the high throughput executor and the TaskVine base version both create 5,025 small files on the shared file system, whereas the temporary file version, because it is not writing back that intermediate data to the shared file system, it only creates 1,005 files, which, because these are the very end of the workflow, the result that we're interested in, it only creates that amount of files on the shared file system. And between the TaskVine base version and the high throughput executor, if we think about the sort of transfers that are going on in the shared file system, even without the temp files, the TaskVine base version is still being a little more easy on the shared file system, because if we run a task, we're producing the file and we are writing it back to the shared file system. However, the TaskVine executor, with some degree of probability, will schedule a transfer to happen in the cluster for the next task to run, rather than tell the worker to get the file back out of the shared file system. So effectively less data will be transferred out of the shared file system using the TaskVine base executor. But these are just the statistics on these 3 runs here. The open question here, which I would really like to hear some people's thoughts on, was how can we express the intermediate data in the Parsl API? Is it possible we could do it automatically? Sort of what do people think about this? Because in the TaskVine workflow system, we're very data focused, and when we declare a file, there's a lot of flags and switches that we give to a file object because of all of this careful treatment of files. We say whether or not we want it to cache, whether or not we want workers to be able to transfer it between each other, and in this case, we declare a temporary file to exist in the TaskVine workflow system. However, in the modification I made to the Parsl executor, at least in this preliminary result getting, I was declaring every output of a task to be a temporary file. And the way that I indicated that I wanted the file to come back is I would set it also as an input to the last task. And so that would sort of get around my declaring every output as a temporary file. If this file already existed, then it's not going to be a temporary file. And so that's not a very good way of doing it. So I'm kind of curious if anyone has thoughts on how to specify some sort of attribute of a file object in the Parsl workflow system. And with that question and the rest of the presentation, if you have questions, I hope you do, and I'll be happy to answer them. And this is a little bit of information about CC tools and TaskVine, some of the people that worked on the project and the places you can access our software and how to install it. Thank you.
Cool, thanks. I can probably give some rambling thoughts about your file stuff, about your file question, but let's see if anyone else has questions.
Okay.
No?
Only answers.
Yeah. So can you go back one slide?
Yes.
Is that these P files, is that the file object from Parsl?
Yeah, it was
You just renamed it.
Yeah, it got renamed. This is from
So if you forget about TaskVine entirely and look at the way that Parsl file staging works, one, it's not used a huge amount because we originally did that for a multi-site use case, and people don't use multi-site very much, although now Globus Compute is getting in a good place where the Parsl multi-site stuff became Globus Compute, and now people are trying to use Parsl and Globus Compute together. So it's sort of come back on the horizon as a thing that is beginning to be interesting again. But what that means is that a lot of the Parsl file handling stuff will seem pretty rough because it's just not had people pushing on it. But there's this model where what you can pass into those file objects is a complete URL, right? Not just a file name. And so you might imagine there you would put a Globus transfer URL in there, and some combination of the Parsl core and your executor magically, what that means is we don't care how that file is transferred, but it comes from that URL and will exist where the user wants it when their task is running. And the same for output files. And that kind of has the same feel for, I guess, what you're doing with TaskVine, that you're just trying to get the files in the right place,
Mm.
magically put into place. And with the temporary file stuff, it's especially magic.
Yeah.
But one thing could be like you name files that are going to go onto the shared file system, or really the submit side file system, by using a file URL, file colon whatever, which is implicitly what you get if you just use a file name. So all of those p files. But you could potentially have another URL scheme that says this is some file that only exists inside the TaskVine cluster. So it's called what have you got? Whatever coords.pdb, but
Mm.
it begins TaskVine colon or TaskVine temp or something colon that. And that means this file is only accessible to people who know how to access these TaskVine temporary files, right? Which is only TaskVine. So no one else is ever going to be able to get at those files. But that's fine, right? Because I think because that's the point of what you're doing. These are files that aren't shared; they only exist
Mm.
as far as TaskVine is concerned, and that would give you a way to put names on files, which would let you wire them together inside Parsl and then inside the TaskVine executor, without anything saying, well, we're allowed to get at these files from outside.
Mm.
Yeah. So I could make like TaskVine colon whatever .text. I could use it as an output file for one task. I could use it as an input file for another task, but there's no promise that that file gets staged anywhere, right? It's
Okay.
just a thing that TaskVine knows what that file name means, right?
So it's sort of a different sort of file object in the TaskVine executor that we
Yeah,
could.
well, it would be the same file object, but that string you pass in is a URL, and traditionally that URL would be saying how you would access that file.
And is there some internally there's some sort of handler that switches on what the URL
Yeah,
protocol is?
yeah. Well,
Okay.
it's pluggable. So when this code was designed, the intention was that that would be separate from the executor. But one of the things that we figured out, I think, when we did the work queue executor, is work queue wants to do some file staging as well. So Parsl core doesn't need to do it, and turns out that's fine.
Mm-hmm.
And that would also be the case here. You would just say to Parsl, when you see a TaskVine URL, just don't touch it, just pass it onto the TaskVine executor. TaskVine knows how to stage its own files around.
Mm-hmm.
And that's the point of this piece of work that you're doing. And just let that magic happen and just stay away. And you want to get at that file afterwards, tough. You can't. It doesn't exist as a local POSIX file on the submit side. Just like an HTTP file doesn't exist as a local POSIX file on the submit side.
Mm-hmm.
Yeah. That's one way of looking at it that's sort of driven by that URL namespace approach. That somehow a temporary file is qualitatively, it has a different name, right? It doesn't exist as a file that's named on the submit side file system, because it doesn't.
All right.
Yeah.
Yeah, that's something to think about.
Yeah, it's a bit weird because we don't have many examples to show, because we haven't pushed on it very much.
Mm-hmm.
Yeah, but like one thing I've done this past couple of weeks is an output URL scheme called zip, and that stages a output file into a zip file, for example, as an example of staging out files somewhere that isn't the shared file system. Like ultimately it does put it into a zip file in the shared file system, but the destination is this other weird place that isn't the path on the shared file system.
Mm-hmm.
Yeah, I can write some more stuff to you afterwards
Okay.
if you want to have a poke at that. I mean, it sounds like it might map fairly well to what you've done already with choosing certain kinds of files should have a particular flag set or not.
Mhm. Yeah, when I was beginning looking into this, I was pleasantly surprised to see that you can declare a file sort of like this in Parsl and say that, this is an output of some task, but
Yeah,
it doesn't really care if it ever shows up.
yeah, right.
If it
Yeah,
never
I mean,
never arrived, it doesn't really mind.
yeah, it's deliberately the job of the staging providers to make that happen, and you just have to Parsl core just has to trust the staging providers do that.
Mhm.
Yeah, yeah,
Okay.
like it's deliberate. It deliberately doesn't care.
Mm.
Yeah, cool. But those numbers as well look nice on the slide before.
I made that issue about Condor provider the
Yeah,
other
I have
day.
some opinions on that as well.
Um, Basically, I've been generating a lot of files, and I'm thinking it's causing me some issues. Uh,
What files are being generated?
well, so the Condor provider
Mm-hmm.
uh, generates a lot of files. It seems like it for
Yes,
each
it does.
block, it generates a file, and then inside, I think it generates a directory, and then inside that directory, it generates these worker logs,
Mm-hmm.
uh, and then it seems to generate more worker logs than nodes I am.
Okay.
Is it almost for every invocation or something?
Yeah,
Uh,
that sounds maybe bad.
okay.
So the context here was for everyone else was looking at getting the Condor provider to launch multiple jobs at once, as if it was a single block. Um, you kind of could do it, but it gives me kind of bad vibes about how it fits the interface. So maybe it's better to look at what that thing is actually doing.
Mhm.
Um, Basically, because a block should map to a job that has a life cycle, like starting. Is it running now? Is it over? Can we ask the status? Can we cancel it? And
Mhm.
I feel like if you use Condor's thing where it will launch 100 copies of a task, you can't really ask questions like that.
Yeah. Yeah, I don't think so.
Yeah. So then the scaling code can't ask questions about how many blocks do I have running now? How many more blocks do I need to launch?
Mhm.
So it feels like a big pit of incoherency that maybe it's better to look at what the Condor provider is doing. If it's doing something wrong, that could do something better.
So is it the intended way of using it to have one core?
I I don't think anyone ever had any particular intention for that particular provider. But in my opinion on Parsl scaling is you should use as many blocks as you can, as small as you can, because you get
Mhm.
much more granular scaling that way. And then big HPC systems are like, we want you to submit 1,000. We'll make it cheaper for you to submit 1,000 node, one block of 1,000 nodes,
Right.
rather than 1,000 blocks of one node. Even though they could schedule they could schedule the 1,000 block case much more efficiently because you can tile the 1,000 nodes in time however you want. So
Mhm.
my opinion is that when you can, we should be pushing on small blocks, many small blocks, um, rather than one big block.
Okay.
So as much as I have an intention, I feel like that's the better way. The Condor provider launching many blocks would be, or many small blocks would be a better thing to be doing if we could make it not make a mess.
Okay. So yeah, the my concern with the scaling was Does that generate that it doesn't generate too many files. I mean, it's on the order of hundreds or 1,000 or something. But also the workflow, this workflow in itself, the application generates a ton of files. If I'm not using the temporary
Yeah.
um, intermediate data, then I end up at the end of the workflow with like 5,000 files in my
Right.
shared
Yeah.
files. And if I scaled that up, then I would have quite a bit more. And
Yeah. Yeah. I mean, I think you have a legitimate complaint,
mhm,
definitely. Um, I would just like to see if there's anything that can be done to make the condo provider less noisy
mhm.
without doing this. Which maybe there is, maybe there isn't.